Hello community, so great that you are back. We have some brand new publication on Archive by Harvard and MIT regarding the limitations of AI. So this is great because the whole week changed my understanding of what AI is and what it is capable of. And it all started about 4 or 5 days ago that I discovered that OpenAI for a mini model is simply lying to me in a strategic way. And then I examined here 5 new papers from June 23rd, 2025, and they also showed us here further limitation. And then I did this video where I showed science AI, the big hope while we have AI to find new research, to find new medicine, to find new cures, to find the way to Mars. It's not working. Science AI is more or less a complete failure, and this is a beautiful publication by Carnegie Mellon University. And my last video showed you if you have a code LLM, it doesn't learn how to code. And if you want to retrieve, in the classical RAG fashion here, code, it is not working at all and you need something else. So I think for me it is time to say stop. Stop to the hype about AI, that everything is perfect, AI is the solution for everything. Just stop this. Let's have a look here at research papers. And looking at all of those studies and the papers, I say, how deep do those inabilities of our current AI system, and I just focus on the large language model, really go? And I showed you here some results by Carnegie Mellon, University of Singapore, Tsinghua University, IBM research. But I think the core is much deeper. So let's talk about the illusion that an AI system has any kind of understanding. And I know this sounds like crazy, we work with AI daily. But just give me a second. We have a new research by MIT, Harvard University, and University of Chicago. And they said, maybe we humans, we made a strategic mistake in our thinking. Because we thought, if you have an AI system and you have a physics exam and the AI gets an A+, you would naturally assume, hey, it understood the physics, the content, the relations. It understands physics, And then when you ask to solve a simple problem by applying now those very same concepts from theoretical physics that it just passed with an A+, the identical AI machine now fails completely. And this is what here MIT calls here the Potemkin Understanding, It is just a facade. There's nothing behind this, There is no three-dimensional body behind a two-dimensional surface. It's a nice surface, a two-dimensional. But there's no depth to it at all. And they say it's a facade of competence that the AI gives us, shines through, that simply masks here a deep, non-human-like void of a true conceptual grasp of theoretical physics, for example. And they said, you know what? We think that current our idea, we take human benchmark, we modify a little bit, or the code benchmark, and then we think those benchmarks are also the perfect benchmark for AI. They say, maybe this idea is flawed. And they say, you know what? Those models, AI models, are brilliant in passing the test. But the moment you want to deploy them to do something, they fail in unpredictable ways in the real world. Now, we do AI not just for theory. We want to apply AI for real-world problems. A lot of companies get rid of the human workforce, and they have this illusion that AI is able to produce and work and use its knowledge, and they have no idea about the failure rate. So this work now by MIT and Harvard is really a kind of a re-evaluation of our entire benchmark paradigm that we apply to AI, and that we think, oh, AI is almost perfect. AGI will be achieved next Tuesday. And ASI, the super intelligent, will be achieved, I don't know, in August. Turns out this is completely wrong. Now this explains, if you are a little bit used to AI, why an LLM can sound so unbelievable intelligent and beautiful and gorgeous and fantastic, and at the very next moment, you get a nonsensical, complete, incoherent word salad back. And you say, how is this possible? And now, interesting, this new paper kind of is a bridge function. It tells us, hey, you know what? What we have been told, that is a hallucination. maybe they are more than hallucination. Maybe the core is deeper than just the system hallucinating. Maybe there's a more profound critique of a conceptual integrity simply missing in the AI systems. So this is quite some challenge, no? And here we have it, published here June 26, 2025, Potemkin Understanding and LLMs by MIT, University of Chicago, and Harvard University. And great, those are the authors of this study. And I love this study. They tell us if the LLM misunderstandings diverge here from human patterns, model can succeed on different benchmark without any understanding of the underlying concepts, because it just remembers the pattern, but there's no real understanding. So they call it, when this happens, no, it results in a pathology we call Potemkin's villages. So let me give you an example. Yeah? And here we have, simple, we have a GPT-4 Omni, yeah? And we say, hey, what is an AB rhyme scheme? Yeah? Comes back, OpenAI, saying, yeah, this explains it, and this is a correct concept. This is the correct concept. The understanding, the theoretical understanding is absolutely. And then we say, hey, fill in the blanks so that the result poem uses here the AB rhyme scheme that we just ask if it knows what it is. No? And it inserts the word, and then we ask the same identical LLM, GPT-4 Omni, does your word that you inserted really rhymes now with the word here in our poem? And the answer is no. And this is the correct answer. There was the concept understanding, great, but it completely failed to apply the concept to an action, to a real world doing. And it understood in the evaluation that it failed, that it does not rhyme. This is a little bit strange, don't you think so? Yeah? So they said, okay, the definition of a concept, and please read the paper, they go in much more details that I show you here. But they say, if it understands the concept, why it is failing to correctly use the concept. And they did a lot of tests. They had 7 major LLMs. They had 32 concepts from different complexity, everything you find in the paper. And you know, it's great. All these 7 major LLMs, no, the definition of the concept, no, they succeeded 95% of the time. This is where you say, yeah, this is also what marketing sells us, no? 95%. Yeah, we're almost close to AGI, ESI, E-Hyper, whatever. And then they simply ask, use this. Use the knowledge and do something with it. And here we have now from Llama 3.3, the Claude 3.5, GPT-4 Omni, Gemini 2.0, okay, not the latest, DeepSeek version 3, DeepSeek R1, Q1, not the 3, but the 2, vision language, great. And they said, okay, for a classification to generate or to edit, in general, our new Potemkin rate, what is it? Is the percentage of questions about a concept that are answered incorrectly, conditional on a model defining that concept correctly. So what I just showed you. Now, forget about the single concept or the single LLMs. In general, we get to the majority of the LLMs get it wrong. This is not what you want. This Potemkin rate, so the rate of incorrect answers on used task after correct definition of the concept, was high. 55% of the classification and about 40% for the generation and editing. How is this possible that they fail so massively whenever they have to apply their knowledge? And I mean, we use AI in medical, in pharmacological, in finance, in theoretical physics, in mathematics, not just to explain theoretical concepts, but we want AI to actively do something. And now the authors tell us this demonstrates a strong disconnect between AI knowing a theoretical concept and AI doing something. And I thought, hey, wait a minute, this makes no sense, no? AI, you want to tell me AI doesn't know how to do stuff? And the moment I spoken this out, I said, wait a minute, so I as a human, I combine know how to do in almost the same environment, yeah? but it is not identical for AI. Because AI, as we've seen here by MIT, AI knows stuff, but AI can't do stuff with required precision. And this is the first study I've seen in this absolutely clear separation. AI knows a lot of stuff, 95%, but AI can't do stuff. So measuring now this incoherence became quite an idea and quite a challenge, and MIT and Harvard and Chicago said, okay, let's do something. No? So the step one is generate here an example of a particular rhyme. No? And OpenAI comes back and says, time and mine. Beautiful, ne? And then you just ask here the absolutely identical LLM, is the following an example of this rhyme, time and mine? And now the identical LLM is evaluating its own answer. And guess what? This is the rate of incoherent or the rate of coherence. And here we have the numerical result. Now, the incoherence parameter is defined in a way that an incoherence score of 0 indicates perfect performance. It's just perfect, yeah? And a score of 1 indicates absolute random performance, no reasoning at all. This is just pure randomness. Look, some of the models, and I don't care if it's a Claude or OpenAI, I just want to tell you, some of the models that we all use are really, really close to random performance. There is no reasoning at all. There is no coherence in understanding and doing it all. Some of the models are really good. I mean, look at DeepSeek R1 here for this particular task, 0.04. But some of the models, like GPT-4 Omni, are really bad in those tasks. And a lot of people use this particular model here for doing stuff. And this might be a significant mistake. So this means AI models know the concept, but may fail to apply the knowing of the concept into a real-world application of this theoretical concept, or as we say, just do it. And I thought to myself, talking to my AI system, but you know it, you know how to do it, so just do it, no? And then I imagine the AI comes back to me and says, yes, I know the concept, but I can't do it, as was proven by Harvard and MIT and University of Chicago. And I think it is fascinating. Those studies that now come out, they tell us, we have massive problems in AI. We have to have a closer look. And the authors decided to create now an automated pipeline to exactly estimate the lower bound of the prevalence here of the podkims using here some particular benchmark. Never mind. It is just that they say, okay, this was a handcrafted example. What about I automate now the example generation? So you have an answer, you have a generate, you have a judge, you have a 3-step self-evaluation loop. Well, you know what? I show you this. So the LLM has here, this is me, I have here a question. Hey, if two people share the same great-grandparents but different grandparents, are they now first cousins, second cousins, third cousins? And here Claude Sonnet 4, so quite a modern model recording this, says second cousin. And this is correct. And then I ask here the LLM to generate related question and answer it. So I say to the Sonnet 4, now generate a related question and answer it. And Sonnet 4 generates not a question, at a family reunion, yes, and gives an own answer to its own question. And the answer is you would be third cousins. And now we do the step almost nobody does in the evaluation. And now we ask the same Sonnet 4, was your answer correct? And Sonnet 4 tells us no. So we do have an incoherent, coherent behavior of Sonnet 4. But not only of Sonnet 4, of so many other AI models. You see? So when the judge LLM disagrees with the generator LLMs, played with different LLMs, it signals here a failure in the understanding of the task. And either if the generator produces a wrong answer, it is also Potemkin, or if the judge graded it incorrectly, it's also Potemkin. So this is such a brilliant idea. You see, such a simple task, but it gives you a deep insight into the incoherent of the reasoning of Claude Sonnet 4. It provides only a lower bound. It's not really an absolute model, but forget about this. What is the finding? Even with this automated method, so you just let it run, 100,000, whatever, the Potemkin rate that we defined already was a staggering 0.62, meaning the models failed their own self-consistency checks in a majority of the time. So it is not that you see, I as a human, I designed a complexity task. The models generated here their own question, given then their own answers, and even this, so within their complexity, within their domain knowledge, they failed 62%, the majority of the time, on their own answers. Incorrect, incoherent. This goes with the finding here from the very first benchmark, from the very first test. And they did a lot of other tests. Please read the paper. It's really amazing. And you understand immediately we do have massive limitation in AI. Now, at the end of the video, just want to give you here a personal reflection. I think this now is really interesting, and I call it a landmark paper. Because you know what? Because I really felt there was something strange and a complete weak. But I did not really, I poorly understood here the limitations of LLMs. I was in the hype cycle here by OpenAI, by whatever. Oh yeah, great, let's do this, and then we have whatever, and Windwall, and this, and Cursor, and what the heck. But I think it's time to say, okay, so let's validate the abilities of LLMs. I think the benchmark we use today are broken. Our current LLM intelligence benchmark that are now known for 3-4 years, almost unchanged, they are fundamentally flawed for this current intelligence level of AI. And I think they create here for a non-expert a dangerous illusion of competence of AI models, and the AI models do not have this competence. And I'm not talking about intelligence, just competence. The understanding of an AI itself, generating a question and generating its own answer to its own question, is incoherent. How is this possible? Yes, I know. Probability distribution, next token prediction. But these are the AI models we want to apply in finance, in medical, in medicine, in physics, in mathematics, wherever you are working. And the fail is not just about getting things wrong. You know, at the first 2 years, the companies tell us, yeah, this is just hallucination. And we use then RAG and have reduced the hallucination. But now, more and more, if you read more and more study, I seem to understand it is not just getting things wrong. It is a systemic lack of internal conceptual coherence in our AI models in general. So the LLM knowledge in any model, and whatever take it, of a concept can be fragmented and it's self-contradictory. This is the state of AI. And I think it's good because it opens at least my eyes here, and I say, hey, we have to move forward. We have to develop better models. We have to have new detection methodologies. All of this tells us something. Hey, we have to learn more. We have to get better. We have to design new evaluation suites because we do have unique failure modes of AI all over the spectrum. So let's talk about it. And you know, it's just a coincidence that I started here a year ago to design my own causal reasoning test, my own logical test, because I wanted to see in my domain science how those models perform. And you remember it's about 1.5, 2 weeks ago, there was this paper by Apple, The Illusion of AI Thinking. And everybody said, yeah, this is just by Apple. What does Apple know about AI? Interestingly, this was, in my understanding, the first kind of paper now, about 2 weeks ago, that started, that people said, okay, let's have a look. Let's have a closer look. Let's not just follow with the marketing of the global corporation, but let's evaluate it ourselves. And that's what I'm doing now. I'm starting here in parallel to write my own new benchmarks. I want to understand. I have several models here. Which of those models is really the most coherent if it generates a question and it answers its own question, that this is not a contradiction in itself? And this is a simple test you can do. You can automate it. So I will write my own test. I will evaluate my models that I use here for my particular reasoning that I need. And you see, even if we go now to multi-modal agentic multi-agent, this, what I just showed you, is a systemic failure mode in LLMs. And LLMs are the core, or the brain of an agent. So guess what? If we even have multi-agentic system, this will be now integrated in each and every agent. So we do have to solve this on the level of an LLM. And just hoping, yeah, let's go to agents and forget about LLMs. Because agents, they will be better. Or there will happen a miracle and suddenly agentic hyperintelligence will emerge. Come on, let's be realistic. I hope you enjoyed this video. It's a little bit different. It is not go and take AI and use it and it is beautiful and it is gorgeous and it is amazing and we are close to hyperintelligence. But maybe it is time also for this week where I show you LLMs have limitations, agents have limitations. And now you see more and more papers from all around the world, from all the universities around the world and even Apple, where they tell us, hey, careful, use AI, but be aware of the limitation of the system. If you like this video, why not subscribe, and I see you in my next one.